Good afternoon, everyone. I am Naji. I'm an SA with Trinempus. Trinempus is a Canadian consulting company. We are based out of Toronto and Vancouver. We do DevOps in the cloud, workload migrations to AWS. We work really, really hard to make our clients happy. We're not the kind of consultants that come in, look at your baby, and tell your baby's ugly while handing you the bill. We work really hard. And me personally, I'm doing a project right now with Shutterstock where I'm doing some Terraform to build some EMR clusters. We do a lot of fun stuff, so a lot of bleeding edge technology. And if you'd like to talk to us about that, please come by our booth. And last but not least, we have a draw for an Amazon Echo. So please drop by, drop us a card, and talk to us. Thanks.
Thank you, Trinempus. All right, we have our first speaker, Adam, and he's going to talk about automating all things, including your brain.
All right, hi everybody. My name is Adam. I'm with VictorOps, and this is already my 4th DevOps Days this year. And the topic of automation always seems to come up at those conferences. So I thought it would be interesting to talk about how our brain uses automation. So I'd like to walk you through an exercise here to start off. Let's take Maria. Maria is mathematically inclined. She's got good problem-solving skills. She's able to think logically. She needs order and structure and has a passion for details. So based on this information, do you think it's more likely that Maria is a professor of mechanical engineering or a registered nurse? Now raise your hand if you think a professor of engineering. All right, how about a nurse? All right, well, Maria is more likely to be a registered nurse, and even though the personality traits that I listed there were more closely aligned to the skills of an engineer, statistically speaking, she's more likely to be a nurse. And this error in judgment is part of cognitive bias, and we all fall prey to this. And so cognitive biases are when you have an error in thinking that affects your decisions and judgments. And so I'm going to go through a few more examples here real quick, and as I go through these examples, think about when either yourself or people that you know do some of these things. So let's start off with confirmation bias. This is when we just go and seek out news feeds that already align with our existing beliefs, or overconfidence bias. Have you ever met someone that claims that they're really good at singing, but then when you actually hear them sing, you don't really have a lot of talent there? The IKEA bias. Shout out to J. Paul Reed for this example. We all know somebody that has built an internal system that isn't really that great, but they think it's the best thing ever, right? Or the halo effect. You guys are probably believing what I'm talking about right now simply because I'm on stage and I have a microphone, right? So there's a ton of these. I mean, I think they're up to about 175 different types, and they're really difficult to identify within ourselves. But once you're aware of them, you're able to see that in other people. And so we like to think that we're logical and objective, but why do we have these biases? Well, it really stems from the fact that our brains create shortcuts called heuristics to automate simple tasks. So over the years, our brains have been able to automate simple tasks like sitting down or typing. I mean, think about when you type in a command line, you don't have to think about every single keystroke, right? And that's because these activities hit the fast part of our brains first, the part that's responsible for memory, reflex, and emotion, before moving to the slow parts that are logical, analytic, and deal with problem solving. And this really is because our brains can't process every single piece of information, nor can they determine every single outcome. So it has to automate part of this process using your experience and your personality to create these shortcuts. And mistakes start to happen when it starts to do this with more complex activities. Let's say your boyfriend or girlfriend over the last couple of months asked you to marry them. What if you only use that fast part of your brain that's responsible for memory, reflex, and emotion? So let's put this into context of our world. You know, most of us in our day-to-day lives at work have to make quick decisions, but they require problem solving. And this is really true when it comes to complex systems like modern infrastructure. So most of my experience within DevOps is around incident management. So let's take a service disruption as an example. You have to respond quickly. Now raise your hand if you're rational and objective in that situation, right? It's really hard because you have constraints. On one hand, you need to make this quick, efficient decision, but you have to balance that with the need to analyze information from complex systems. So take a step back and try to engage that slow part of your brain. And during a service disruption, collaborate. Work as a team. And that's one of the best ways to deal with this because you can start to identify it when others are experiencing this. Some other recommendations for your incident management process is to have a facilitator during postmortems. They can also identify when this is happening. And have documentation like runbooks. You can have historical information that could give you the ability to possibly remediate this issue that you're working on. So in conclusion, our brains automate these simple tasks to really help us out. However, when it comes to complex activities like a service disruption, a marriage proposal, or just other areas of your life, just take a step back and engage that slow part of your brain. So thank you.
Thanks, Adam. All right, so now we'll have two sponsors come back to back. So first we have Logs.io, followed by VictorOps.
Hey everybody, my name is PJ. I work at Logs.io. We are Elk Stack as a service, so if you're familiar with Elk, it's Elasticsearch, Logstash, and Kibana. We put that together. We take care of all the maintenance and upgrading. So all the pains, if you've ever used the Elk Stack, we take those away. You just point your logs at us. We display them. We're really happy to be here in Toronto, home of great things like Poutine, Degrassi Junior High, and the Bare Naked Ladies. I guess they also have a hockey team. If you want to come talk to me about that, I'm from Buffalo, so we have things to talk about. But yeah, we are happy to be here. If you're looking for a monitoring, analytics, logging solution, please come talk to us. We're out at our booth. We're also giving away an Amazon Echo Dot if you're interested in that. Stop by, and we'd love to hear from you. Thank you very much.
Hello, folks. My name is Drew from VictorOps. We're proud to be back here at DevOps Days Toronto. This is our third year in a row. We sponsor all the DevOps Days across North America and now some in Europe. So again, it's a pleasure to be out here with the community. For some of you out there who are already using us, you know about what we're doing. For some of you that don't know who we are, come check us out right when you walk out back and find out how we're trying to make the on-call experience different. So again, we appreciate you guys. Thanks.
All right, after VictorOps, we're going to present our next speaker, who is actually an alumni of the DevOps Days event. He was an organizer for the last couple of years. We're happy to have Felipe back and present his talk for whether for cloud first or DevOpsing with governance, legal, and InfoSec. Felipe, the floor is yours.
A lot of organizations have started implementing cloud-first policies, and we're one such organization. They do this because they want to start benefiting from the services that are maturing in the cloud, and so I'm going to share our experience. So first, early on, we recognized the importance of working with the ones I affectionately call now the risk experts. Basically, all the guys and gals that have been helping your organization secure your company. Because in the new world, no matter the model, no matter the promise of managing less infrastructure, there's one thing that cuts across, and that's the risk. You have to manage the risk. So what should you expect when you first instantiate cloud-first policies? Well, if you're like us, there's going to be pent-up demand. These services are available to everybody, so everybody is free to ideate about how the organization could benefit. So it's really going to be about you weighing the rewards versus the risk. The rewards of having happy and efficient developers versus the risks of diluting yourself and going after too many products all at once. This is key because you want to offer the service as soon as possible to your customer, but at the same time, you want to minimize the risk to the organization. So how do we do this? The tool we use is called a vendor risk assessment. Basically, it tries to gather all these different types of risks together for the customer, so they can make a conscious decision about what risk to accept. Pulling this together is difficult because there are many parties involved. So what we found to work best is to work as a single team and to teach other team members about agile practices to make backlog visible. If there's one slide I'd like you to remember, it's this one. Fail your providers early to protect your risk experts' time. Find any way you can to fail them early. The first trick is really simple. Know what kind of data you're going to be putting in that service. If you know it's confidential data, it'll make things very crystal clear. The same if it's just simple data that you're putting up there. If you have knockout questions that you've gathered over time, why not push them down to the people bringing you those products so they can get eliminated before they even come to your backlog? Along the same lines, if you know the minimum requirements that you need from your risk experts, basically any service that you're going to touch is going to require NDAs. That makes your life a lot easier because you know exactly what you need to attain. Here's one trick that really helped us. Don't wait for the full risk assessment to be done. Do an early risk assessment review and decide if you want to continue or not. It's really key. Because in the end, you'll notice that your providers may not have the maturity they seem to promise in their marketing, or doesn't meet your maturity. So you have to be ready to walk away or ready to implement something else. Marketplaces, who doesn't love marketplaces, right? Services that you can use right away. Well, terms and conditions on those vary wildly depending on the platform, so you should pay close attention to those. Even if you're moving workloads from internal data centers to an IaaS cloud, there are still risks you need to manage. For example, the license agreement risk. That's something you should tackle with your legal team. In the end, it's about you reviewing that vendor risk assessment with your customer and making a conscious decision about accepting the risk, whether it's acceptable or not, and recording that decision. To come up with all these tools, the one thing that was very helpful to us was to include feedback and do retros regularly, and to fail faster and faster and faster. So I really recommend you do that. In the end, if you know your data, you know what you want from the service, work as one team, perform team retros, and include feedback, you'll be in a good situation to deliver services quickly and with minimal risk. Thank you.
Thank you, Felipe. Next, I'd like to invite our next sponsor, Pivotal. Bridget's going to be back on stage.
Hi, thank you. Okay, it already says time's up. Oh, I thought I was done. All right, you already heard enough from me, but the part that you didn't get any kind of strong pitch on, and you're not really going to get now, is my employer, which is basically, you have a lot of choices. You have a lot of choices. You're in this room in tech right now, which means you have a lot of choices of what software to use. You have a lot of choices of where to work. We are possibly relevant to both of those interests. The Pivotal office in Toronto is less than a mile from here. I looked up the address to tell you what it was, and it looked fake. It was like 1 Toronto Street or 1 Toronto Place or something. And I was like, is that real? I don't know. Anyway, if that's a real place, and I have been there, I just didn't remember the address, but if that's a real place, imagine yourself working there on things like Cloud Foundry, like Spring, the Concourse.ci open source, pipeline first continuous integration tool. There's a lot of really cool projects you could work on. But if you're thinking to yourself, but I really like the enterprise that I work at and I want to make it better, cool. Like we want to make it better too. So probably the enterprise you work at has some things that you're doing to meet your goals, whether your stakeholder value goals, whether they're in government or in the money-making side of the house that a lot of us are on these days. And you probably probably don't want to be spending a lot of time on the undifferentiated heavy lifting. That's exactly the stuff that you could build, but why? You want to build your applications. You want to give value to your customers. So if you want to look at Cloud Foundry, it is open source. Pivotal offers a supported Cloud Foundry with a lot of good add-ons for giant enterprises. If you work at the sort of place that likes to buy that sort of thing, come talk to us, get a demo, see if you like it. And we're hiring. Thanks.
Thank you. Pivotal is right outside, so feel free to mingle with them. Next, we have Niall, and he's going to have his talk around Dockerized development environments. The floor is yours.
Hi guys, my name is Niall, and well, I've gotten the privilege to work with a few development teams that have been interested in sort of newly adopting Docker as a technology, and I thought it'd be fun to talk about some of the curveballs, but some of the stuff that worked really well as that kind of came about. That adage right there on the screen is like particularly true. I have found that with every sort of advantage Docker brings, there are some like curveballs that'll throw your way. There are solutions to all of them, but it's nice to know about them going in. So why would you do this if there's going to be problems? Well, if you do it right, you get this great development environment as code that's living in Git. It's under version control, and it's really simple to provision. Your devs can run a script. They're up and running in minutes. They've got the freedom to choose the platform they want. They can use all the IDEs that they're already accustomed to. It's very flexible from a dev's point of view. That being said, the dev environment is the ideal place to try this out, or so I found myself. It's a lot nicer than tapping the ops guys on the shoulder and asking them to try Docker tomorrow. Yeah, devs are pretty responsive and they're pretty energetic to try it out. Now you might already be using Vagrant to solve some of these problems, and you might say, well, why not use that? You'd missed out on the faster boot times of Docker. You wouldn't be able to build the more exotic, scalable build systems that I'm going to talk about in a minute, and you wouldn't start down that road towards no ops, which containerization seems to promise. For myself, starting out, I found that a single container worked really well just to run and build the code, having all those system dependencies to sort of wrap around the code as a nice blanket. One container kept it simple and easy to manage. From a dev's point of view, this meant that they just did a regular sort of Git clone. They pulled down the code just like they normally would. They would run a script, start up the container, and everything was pretty transparent. The code would be dynamically mounted inside the container, which meant for the devs, they type on their IDE and the code inside the container changes in real time. So it was pretty seamless and, again, pretty dev-friendly if you do it right. There are some gotchas that I am going to talk about in a minute, but from the 1,000 yards, it does look pretty easy. Once that was running really well, I found it like kind of a good idea to go to more of a 12-factor design where I split the run and the build steps into sort of like two different containers. This just meant pulling the compiler out of the runtime container to keep it sort of lighter, faster, easy to manage. An old colleague did something called donutting with these two container patterns. He would build his binaries with one container and sort of drop it like a Timbit onto the host machine. Then he would take a second runtime container, minus the compiler, put the Timbit inside, and now you had this sort of portable runtime environment that you could move around to different systems. It was a pretty nice way of versioning everything. Now, I have also found that you can do the same thing with interpreted languages. It's a little bit more complicated. I haven't come up with a good name for it. There may be one out there. I called it offshore building. You probably have a better name. The whole idea is that instead of building binaries, you actually build your packages. So your NPM or your pip packages or whatever, and you deposit them onto your host machine. Then the cool part is you take that Timbit of packages, put it inside a Scratch Docker container, put it up in your repository. Now you're protected if the public system ever goes down. You've got your own built versions ready to go. You just simply anchor them beside your application container, and you've got this really fast way of deploying packages, and they're the same for everybody, and if you go to prod with Docker, they're the same in prod too. So it's this like really, really neat pattern that sort of just emerged. I can't take credit for discovering it. I don't know who did. If you're on OS X, there's a couple of gotchas with Docker that you need to be aware of. I learned about them the hard way. Definitely build a wrapper script to start up your environment, and then you can take advantage to some of the workarounds that are out there, and there's some great ones. The thing you need to be most aware of is the slow OSX file mount behavior. That dynamic code injection into the container, super slow on OS X right now. They're working on it. Don't put a million row SQLite database in there. It's not going to perform very well. What you can do is check out a couple of projects on GitHub. There's something called Docker Sync and Docker Unison, and they kind of manage this problem very well. I have found most of the time it's not really an issue, but if you are doing something read or write intensive, you do want to check those projects out, particularly if you're a Ruby guy. The other problem you want to watch out for is if you are inserting native like Mac code into the container, it's going to be case insensitive, which doesn't play well with Linux. Do yourself a favor and create one of those like sparse bundles, make it case sensitive, and run your code on top of that. It'll save you a lot of file name collisions. If you jump on the Shared Vision Solutions GitHub repo, you'll find an example of a solution for this and for the offshore build pattern that I mentioned. Thanks a lot.
Thank you, Niall. Up next, we'd like to invite two of our sponsors, Blended Perspectives, followed by PagerDuty.
Hi. My name's Jira. No, it's Martin. Jira, 85,000 customers, can't be wrong. Atlassian is the market leader in application development lifecycle with seamless solutions, end-to-end platform spanning collaboration, planning and agile, Git, code repositories, CI/CD. Atlassian really is a solution that is social, team-centered, and focused on transparency, collaboration, and automation. Being able to draw your team members into a social experience is critical to making DevOps part of that bigger getting software out there solution. Blended Perspectives is a platinum partner for Atlassian. We're a full service shop, meeting their highest standards. We understand your organization and your enterprise. We understand your processes and the technical challenges. We can make the Atlassian suite sing alongside other solutions, including DevOps components. So one way or another, we'll make the Atlassian solution better and less expensive for you and less expensive than buying direct from Atlassian. So in short, we're here to help you provide a seamless application dev stack solution. We have an Atlassian DevOps event on June 20th here in Toronto called Escape the Chaos. So come visit us, win some prizes, and I hope to see you on June 20th. Thank you.
Hi there, I'm Paul from PagerDuty, one of many here today. Who all is using PagerDuty currently in their role? And who else has heard of PagerDuty? Okay, so this is for the few people that haven't put your hand up, but PagerDuty is an end-to-end incident management platform which does everything from small operational issues, including on-call management, disk has failed, needs replacing, all the way up to dealing with major incidents that need whole team responses, mobilizing multiple teams from multiple different groups, bringing them in, informing stakeholders, and dealing with everything needed to deal with large fire drills, including whole DCs going down, et cetera. We provide a lot of functionality beyond resolution as well, including our recently introduced post-mortem support, which makes it really easy to build post-mortems and takes all the pain and suffering out of this usually tedious process. We've got a lot of presenters here at the show. We've had Mia Henderson this morning talking about Docker containers and the agony and ecstasy, and our own Dave Cliff will be presenting an Ignite talk tomorrow. If you're in the business for a new business, we also have a large Toronto office and are actively hiring, so feel free to drop by our booth and talk about our product or about working at PagerDuty. Thanks a lot, and we'll see you around the show.
Thank you, Blended Perspectives and PagerDuty. Next, we'll have Peter Chestnut talk about full spectrum engineering, the new full stack. Pete, the floor is yours.
Thanks, everybody. So my name is Pete Chestnut. I'm the Director of Developer Engagement at Veracode. It means I get to go out and consult with companies around DevOps and Agile. I want to tell you about what I see happening in the market today around developers and development teams. So when I talk about DevOps teams, I mean people that are responsible for building that. So my premise is microservices, the smaller architectures, our move to DevOps have changed the way we have to think about building software, the things that we have to do as developers and developer teams to build it. Take a look at N-tier architectures. These were very much siloed. We had DBAs, we had people that wrote middleware, we had people that wrote front end. That's all changing as we've moved to the kind of microservice architectures from the monoliths, right? So Now it's more fluid in the way we interact with the back end, in the way we have to write that software. And developers, as we've sped up, have to think differently about how they write that and what they're responsible for. We don't have time for handoffs. Take a look at the web technologies. In the early days, it was very much cut and dry. We had people on the front end, we had people on the back end. Moved to HTML3, and now I have to be more of a generalist. I have to know a lot more of these technologies and be able to build out my whole feature as I go. So this is what I would say is my typical full stack engineer that I hire from my team today, right? It's going to be very similar for you. There'll be a couple of languages in there that change, but this is what we think of as your ideal developer as we're trying to hire them. But as we move to DevOps, and especially single piece flow, we have to think differently about how we build this software and what are the things that we need to worry about as we go through the process. So writing a small change and writing a small feature and getting it to production as quickly as possible becomes really hard. The way we do software today, very much siloed, right? Developers, quality, security, IT, operations, all these people interact with us and do handoffs around how we get software and value to the customer. And to get to real full value in DevOps, it looks more like this. Right? Individuals are building out, they're terraforming, they're doing their own quality, they're doing test-driven development. I have to do containerization to understand the things that IT used to do for me. And operations, the team does that stuff now. It's not an individual. So this is what I'm calling a full spectrum engineer, where I have to be more multidisciplined and not multi-technology. So thinking about all of the aspects of how I get a feature to my customer. So we'll start with developers. You have to be a great developer to start with, or else all this stuff falls apart. Keeping up with design and understanding new architectures, keeping up with developing standards and frameworks and libraries and how they can help you get your features to the field faster. Next is going to be quality. So this is where, test-driven development, when we moved to Agile, we started doing these things and understanding that quality was our job and we're responsible for it to make us have better outcomes. Writing more unit tests, that's really something over the last 10 years that's really come into the fray. Deployment, now this is, again, IT, systems engineering used to do this stuff for us. We have to pick our operating systems now. We're writing these containers, we're building them and deploying them ourselves. Operations, right? So we have to write good telemetry. We have to understand, is our software working the way we intended to or not? If it isn't, then what can we do about it? When the pager goes off, we need to know what to do about that and be responsible for it. Security. So I come from a security company. I've been doing it for 11 years. It has to be part of our definition of done. Most attacks come through the application layer, yet we weren't trained for this. It's a skill that we need to pick up as developers to ensure that our software is secure when it gets to production. So what about those DBAs and other specialists that we have in my organization? There is still a place for them. If they want to become these full spectrum engineers, great, but we can also take the tact of building them into guilds and having those specialists train other people, cross-train. We don't want, a bus factor of 1 on any of our operations or development or quality on our teams, so we have to become more generalized and have birds of a feather meetings, have them set the corporate standards, have them help you set out and teach each of the teams. Again, we're talking teams of 6 to 12 now, not teams of 50. So how do you get that technology and that understanding of how to do these things at the 80 to 90% level to these teams? So in conclusion, the way we build software is changing. The amount of stuff that we need to do and the time frame we need to do it is shrinking and changing. We need to build better cross-functional aspects into our developers and our development teams. So hence the full spectrum engineer. I would love to continue this conversation with you, so hit me up at the conference or follow me on Twitter. Thank you.
All right, thank you so much, Peter. Next, we have LoyaltyOne, our next sponsor.
Yeah, thank you very much. I'm Graham from LoyaltyOne. You probably not heard of that, but heard of Air Miles, our most popular loyalty program. Last year, Air Miles moved almost $1 billion of rewards into consumers in Canada. LoyaltyOne is it's a medium-sized company. We've got about 300 developers, lots of different DevOps teams, different practices. I'm on a team that's implementing the SEC part of SEC DevOps. If you look around the room, I just ask everybody that's from LoyaltyOne to quickly raise your hand, and all those people are very open and welcome to speaking to you about all the opportunities that we have ongoing. Thank you.
All right. How are we doing so far? Good? Pretty fast-paced, if you ask me. All right, next we'll have Jeremy for his talk. Jeremy, the floor is yours.
This is Rafe. Rafe recently became the VP of a corporate services group. He's an old friend of mine who believes in doing DevOps, so when he asked me to join one of his teams, I decided I would and try to do the DevOps with them. I asked him a bit about the team that I'd be joining, and he told me they supported business planning and financial analysis, and I thought, great, I don't know anything about that. I asked him about the technology they were using, and he told me it was a pretty broken implementation of Oracle Hyperion, and I didn't know anything about that either. You see, the implementation was put together by an external consultant using good old waterfall know-how, and then handed off to an internal team to support. They didn't really understand the solution. There was no automation. There was no DevOps. So we brought in another consultant to say, hey, what's going on here? And he came up with a list of reasons it wasn't working for the team and a recommendation that we rebuild. Everybody agreed if we were going to rebuild, we were going to do it right. So the first decision we made was we were going to use the new Oracle platform called eBPCS, because that's easier to say than Hyperion, and that we would, it's a SaaS solution, and that we would retain the Hyperion consultant to help with the Hyperion bits, and I'd be there to help with the DevOps practices. But how do we do DevOps here? You see, the typical workflow is to have a developer do the dev part in one environment, write a run book, throw it over the wall of confusion for ops to promote. All the promotion would be manual, and all the testing would be manual. To make things a little more complicated, once it was promoted to production, business would be making changes in production. When you got one group doing changes in dev and another group doing changes in production, you get this real environment drift. You start building something in development, you test it, everything looks great, you promote it to production, and it just doesn't work. So we had to protect against this. We needed some automation. We needed to be able to build the entire system from source. We needed to be able to know that our changes made in dev could be safely moved to production, and we needed tests, automated tests, that would catch anything, any breaking changes. But all that automation is going to start with source. So to get source control really working for us, we needed to understand our artifacts. Well, we knew that the data could be exported as CSV files, and that our schema, the dimensions of the cube, could also be exported as CSV files. But there was a lot more to the configuration than that. So we looked at how ops was moving the promotions around, and they were exporting these snapshots from one environment and moving them to another to import them. So we started to look at those snapshots. What were in these zip files that they were moving around? We started using tools like Beyond Compare to really analyze what single change snapshots would look like, and we learned how to make a snapshot out of a single change and then get that into source control. So we were getting there. We had our dimensions as CSV files in source control, and we had our data as CSV files in source control, and we had our configuration changes as these snapshots, all stored nicely in source control. But we still needed to automate, so we started looking around for what was out there and found a tool called EPM Automate that Oracle provided. Luckily, it's a command line tool. So once we've got a command line tool to help us with that, we could wrap it up in PowerShell, and we were using TFS, so we could use TFS build and release to automate the deployment of an environment, which was awesome. So we could now pave and rebuild an entire environment from source. It was awesome, but it would take about 2.5 hours to do that because of the limitations of the system. So we decided that we'd run this every night. And every morning, that meant we'd come into a brand new, fresh environment, and we could add test automation to the tail of that deployment, which meant that we could come in the morning and get those test results and find if we had any breaking changes. So we're pretty pleased with how far we've come. We've automated our deployments, we've automated our integration and testing, but we still have a lot further to go. One of our biggest challenges right now is how to deal with those production changes. If business is making those changes in production, we need to be able to detect when those changes are happening. We need to extract those changes out of production and get them into source control so that when our developers are making changes, they can safely know that they're making those changes safely against what's in production. We can take the changes from production and from dev and integrate them and test against it in our integration environments. We'd also like to stop throwing zip files in source control. We'd rather take the components of those zip files, put those in source control where the developers can actually manipulate them, and then have our build release pipeline compose the snapshots. So there's probably more that we could do to be more DevOps, but we're on our way. Embracing a culture of continuous improvement is the best way to do DevOps. Thanks a lot.
Thank you.